Okay, 102 students, I got a good question here about chapter 7, number 16. And it is really relied or going back to the definition of work. And this question is trying to address a fundamental concept of work that's a little bit hard to, what's the word I'm looking for? To accept. I guess you might say it's a nitpicky rule. But because it leads to the principle of conservation of energy, it's important that it be nitpicky, okay? So when we say work is force times distance, we clarify that by saying it is the amount of force in the direction of the distance. So maybe I should just put here amount of force in the same as the D. So there's not really an issue if, say, the force is to the right and the D is to the right. You just take, the number, say the force is 4, and you multiply a distance, say, of 3, and you just multiply them together by 12, and get 12. And the units, of course, for force are newtons, and the unit for distance is meters. That is given in the honor to joule, and so you get 12 joules. Okay, so that's the easy case, and maybe even a case that you saw in middle school or high school. It gets a little bit harder, though, when you have something that is like this. What if the force is straight up, call it 4 newtons straight up, but the movement is horizontal at 3 meters? Well, in that case, and this is why we've kind of been trying to learn about our vectors, we even did a lab on vectors, we've got to say, well, how much of the 4 is in the direction of the 3? So it wouldn't be the full 4. So you wouldn't just go 4 times 3 like we did back here. And in this case, if the force is purely up, then none of it is horizontal. So when you say force times distance, you would have to put a 0 force, because that's the amount of force that's in the direction of the 3 meters. And 0 times 3 is 0. And of course, I guess it would still be newtons times meters, so 0 joules. Now, if the force was kind of at an angle, let's say, so we've got 4 newtons, and then we move horizontally 3 meters, well, then there is some force. Well, let's say it's angled enough so that that's equivalent to being 2. Well, then, of course, when we say force times distance, what we mean is a force amount of 2. So it's not the whole force. It's a fancy word is the component of the force. It's the amount of force that's in the direction that it moves. So in this case, a 2 times a 3 would be a 6, and a newton times a meter would be a joule. So even though these 3 examples I'm trying to illustrate each have the magnitude of the force the same and the distance the same, the angle between them is different. And so we have this nitpicky definition, like I said, is real important. Otherwise, you wouldn't have conservation of energy. But this nitpicky definition results us to think about how much of the force. Okay, so with that said, that's why number 16 is here as a conceptual problem and trying to get you to think. Because it's not a matter of how tired you are, and it's not really what your muscles are doing. Sally's going to be tired because her muscles are doing a lot more work than Bill, and I get that. And I think that's what makes this problem harder is you're thinking of yourself doing the work, and you're thinking about how you're going to be tired. And so Sally and Bill. But see, this is not really what this question is about. This question is about how much work is done on the bag of flour. And it turns out to be the same amount. See, here it says, Bill's job is to lift the bags of flour and place them in the back of a truck, which is parked right next to him. So Bill applies a force probably roughly equal to the weight of the bag of flour and lifts it up a distance of, whatever the typical height of a truck is. I'll call it a meter plus. And those are in the same directions. And so this is like scenario number one. And you go, okay, so you just multiply them together. It's the amount of force, which is equal. I shouldn't use a W. That might look like work. Let me just call it mg. And so you would just say mg is the force and the distance is d. And so that would be the amount of work we might contribute to Bill. Okay. Now, Sally admittedly has a harder job here. She's got to lift it up roughly, presumably, about the weight of the bag of flour. Maybe she just kind of lifts it up to the height of the truck at first. Then she carries it across the floor, presumably still lifting up though, just hold the weight of the bag of flour. Now, maybe she gives a small little tug to get it to start to head in a horizontal direction, but she kind of gets that tug back, if you will, as she has to slow it down and she set it in the back of the truck. So those two kind of balance, or you can say they're minor compared to this part of it. But here's the point. Let me call this D1 and T2. She's got two different movements, but while she is moving the bag horizontally, this D2 with her force up, there's no work being done. Again, from this strict definition. And I should say there's no work being done on the bag of flour. That's not to say that her muscles of her legs don't contract and move across. So every step, there is a force and a distance in the direction she is moving. And so every step, her body is getting tired. The muscles are doing work on her body. So again, this is where I want to be a little careful. And it's kind of hard, any physics problem, to then associate with the human body. And so I appreciate this problem because what they're trying to illustrate is something very important. It's the amount of force and the direction it moved. But it can also be very confusing for students. So I just want to keep saying that this question is asking for the work done on the bag of flour, not the work done so much by Sally, if you will. Or maybe it is. It's just kind of a question that's getting you to think about it. So if Sally is talking about how much work her body has to do, she's going to be tired and she deserves to be paid more. But on the other hand, if you're talking about how much work was actually done on the product, on the flour itself, the answer is the same because this part of her movement doesn't contribute any work. And that's really the goal of this. So I'm not so sure the question is as great as it could be, but because it tries to incorporate a little more complexity in here about biological beings and then the muscles, and it's really easy in this problem to think about the amount of work that Sally is doing on her body versus, or Sally's muscles do on her body, and therefore the calories she burns versus what does she do on the bag of flour. And I really think that the point of this problem is about the bag of flour. And because of that, then, I would say that the only work that Sally does is the mg, and then it's the same distance up. And the distance number 2, there's no work being done. So you might say plus 0 is Sally's total work. And so again, they come out to be the same. Well, hopefully that was helpful.